Hello everyone. My name is Mustafa Can Gursesli. It is my last year in PhD. Actually, I start my last year with this month. But today I will explain you my research project, but more technical part of my research project because basically my research project focused two different type of the area, which one is the engineering and another part is psychological part of the games. But today I will explain you how we are using eye tracking systems and eye tracking analysis for the basic games and how we are using for the serious games. So the first the first research results and a paper I want to show is eye tracking correlated in the matching pair games. Basically, matching pairs games is a really basic one. When we were child, it was like we were trying to open the cards and try to match them. But before to start deeply this paper and in total focus, our total focus, I want to introduce to understand of video gaming and the definition. So video games are started in the 50s and late 50s with the Pong. Pong was really basic, and it was in that time it was hard to organize this kind of video games. But Pong become of the first initial wave of the ocean, let's say in this way. Then this market gets years by years and become bigger and bigger, and now this area is really big, and there are like 3 billions of video gamers and different type of video games. And in these different type of video games, casual video games is a one part of the game. Basically, casual video games means short accessibility, single gameplay, and play sessions. Basically, there are no that much long additional way. You don't invest these games more. They start and they end in a short period, but you can play more and more. And these games, we can give some example like Candy Crush Sagas, Angry Birds, and Tetris, Snake, and basic card remember memory games. So impact on the industry. These games, when the casual games started to become really popular, after game industry become really complex, such as MMORPGs, such as mobile games and internet related games, online games. And maybe you remember, maybe some of you remember MMORPGs like a World of Warcraft become really successful, huge successful in 2005 or something like that. And after as time goes by, industry become more not complex actually. Like 2023 right now, we are discussing about hyper casual video games. Like maybe you heard that before. Some of the games like Hades, it's not it like casual, but also it's not that complex game. And when we are discussing about these kind of games like casual video games, it means we can arrange everyone in this way, like child, education, elderly people, and adults, of course. And the idea of this project using casual video games to arrange people as we can and try to understand their eye tracking and how we can implement for their health. We start for this one, and of course, indie gaming is developing so fast. That's why I give an example uh, like a pixel art games and hyper casual video games. But aim of this study, of the purpose, we were saying like how we were focused and how we catch everyone with casual video games. Because if you were talking about like complex video games, these games really, maybe some of you are playing video games, but some of video games just uh, audience for the some part of the people. But if you have phone and you can open basic video games like a Snake, everyone probably, if your age is enough, you play this game because Snake was so popular and it was so easy and not complex game. So for this study, we choose card memory game, basically matching pair games, and we use this game as a tool to understand how people, while they are playing this game, how their eye movements are moving, and how we can understand these memory recalling affect their eye movements. In this way, we can understand elderly and fragile people affected by the normal adults versus them. It is initial results I will show you, and we published this paper in Jam 2023 conference in IEEE. And there's a small example I want to show you. This is a matching pair games. Some of you probably played that in the past. So I want to share with you our materials and methods. So basically, we use Tobii Pro Glass for this, and the rate of the signal was 50 hertz. It means every seconds and 50 results. And our initial data collected with 18 healthy volunteers, and we gave them 3 trials. Actually, some of our members did this experiment already, and first 3 trials we gave them pairs, and these pairs were 12, and they had to complete this task in 35 seconds. Okay, this is in the left side, it's a real-time eye tracking, and the right side is some sort of equation we are using to simultaneously how the eye movements are representing in the board of the game. Basically, you will see red dots here. It means how the participants are looking in real time, and in the right part, we can see how in the game board you will see that. But when the red dots are when the dots are bigger in the right, it means focus time. I mean, we call it saccade. Saccade time is better than expectation. You will see that right now. This is trial 1. As you see, some of the green dots are bigger than the normal, and there are numbers. So basically, this means the participants focus that area longer than the other dots. It means saccade. Also, we know from the previous studies, longer saccade duration means more cognitive load. Basically, if you are trying to remember something, you focus more that area. Just try to understand when you are reading something. If you don't understand the concept when you are reading, you are just focusing that area, right? It means you have cognitive load is normal than longer than normal because you are focusing that. And these green big dots representing that. Basically, participants are trying to recall and try to remember from their short memories. And this is the second trial. Probably participant is always trying to remember right side of the cards because she or he already remembered the blue ones, and there is no saccades that much. When they fail a lot, and their saccades are focusing that part a lot, basically. As you see, right side. Okay, so these are initial results. Basically, in the first one, the first results show us the raw eye tracking data, which means we normally, when we are doing analysis of this data, we filter them. Basically, as you see, there's a lot of jumps. And the second one is also another raw data. After the filtered the data, you can see how the participants mostly focus X and Y coordinator. You can see that. Okay, I want to share with you our initial results. And results show that maximum eye velocity different than between the first and second trial. Okay, what that means. Basically, when you started to open the cards, the first trial, you know this game right before, but when you started to play this game, your maximum velocity is different than the second game, because as a human, you are trying to solve the problem. And when you're trying to solve this problem, the first trial, if you are not success enough, which mostly we don't feel enough successful when we are doing first trial, we change our strategies. And when we change our strategies, your eye velocity changing that much. So basically there is first and second trial, significantly different our maximum high velocity. Don't forget, when you are, it means your maximum high velocity. Maximum high velocity also means scanning velocity. So basically, you are trying to scan and understand what's going on in the screen. So it means first and second trial, there's a significant difference between eye velocity and eye movements. And in the other trials, there is no, because probably people are not changing their strategy by the results. And also there is unconsciousness scanning theory. It means when you are opening one page of the screen or one page of the book, you started to scan unconsciously what's going on there. If you open the second page, you know where you're gonna start. But in the first page or first screen, you are not sure what you're gonna do. And there are other results. So significant correlation were identified between trial duration and total number of the flip cards. So basically, people, when they have saccade counts related to trial duration, it means when the trial duration, it's in our case it was 35 seconds maximum. After the 35 seconds, they are game over, right? But there is a significant correlation between when game going higher and longer, there is a saccade duration is also going longer and longer. Okay, what that means in real life. So when you are trying to solve a problem, your saccade duration is focusing more. It means you are forcing yourself to remember. We call it recalling. It means people are let's say struggling to remember, and they focus more the card game. Also, another one, fixation duration is correlated between trial of the duration. It's quite normal because we are trying to understand and remember something, but we cannot. So you focus more. It's relation. There is a significant relation from the literature. We know cognitive load relationship between your eye movements. So there is another relationship between negative relationship between number of flipping cards and minimum velocity. So basically, when the number of opening cards are increasing, minimum velocity is going down. It makes sense because when you are opening more cards, it means you are failing a lot. So you are trying to scan more and more, slower and slower, trying to remember that. Basically, our eyes representing what our conscious is doing. Because do you know what's the term of English? We say doze off, right? Because you just focus somewhere, but basically you are not focused somewhere. You are thinking about something. It means you are your mind trying to understand and conceptualize something. So also, as I told you, slow scanning and strategy change, as I told you from these results, there are some different results we found. So for this study, we found interesting results because also there is important questions. First, we gave 3 trials. Why there is significant question 1 and 2? I mean, hypothetically, yes, they are changing strategy, but what kind of brain signals are changing? What kind of brain areas are working when they are changing strategy? Because we understand, okay, they are changing strategy 1 and 2, but what about brain is doing in that sense? What's happening? Also ECG, also EPG, or gallblading skin response. We don't know. Oh, this is the beyond of my. I mean, this is the second part of my study, basically, from the bioengineering sense. So. Second study I want to represent you. This is our design together with my friends and my colleagues, Mirko Andrea and Korean professor and Professor Lanata from engineering department. Basically, we created a system, online system, basically gives a chance you can put your eye tracking model inside of this system, and this system can usable on internet. Basically, you can open this system on your computer, and I can follow your eye tracking data every second by your camera. We didn't improve any model. We directly created cloud-based real-time eye tracking monitoring and storage system. So what was the aim of that? basically, as Professor Guazzini mentioned before, the idea of VirtHuLab is creating a sustainability of the data, right? We are trying to collect data from people. So what's the best way of this? Create a model, create a system, say system from the internet. So if I give you one website and you can open this and I can see your data from your webcam, and this data is alive, it means I can see your data every second, or I can storage the data. So we use REST architecture. It's quite famous. Google, Microsoft, Facebook, Meta, everyone is using this technology. So we use this technology, adapt to how to use these data collection strategy. So as you see, it's a system implementation. First part, let's say experiment platform, and we are doing experiment. And in this platform, we have game, which you saw the first study. There was a data collection, and we did. Thank you so much. We did this, right? And if we use this system, basically, as you see, we put our game itself, and this system basically in the A platform, you can implement like game, okay, reading test, or attention test, or watching movie, okay. Everything is possible. So in that area, eye tracking model here, and there is our experimental point, right? And these two systems are connected between each others with WebSocket. It means when you start your data collection, I can see your data every second. WebSocket is kinda old, and also still used like a famous system. It means two websites are connected with each others and request each others. When they are open one, another one is triggering together. So when you start your data coming here, I can see your data another website every second. So, and after that, I see your live results. When your data collection is done, automatically your all data goes to SQL Server in data management. We use front end and back end differently, but the main part of this project, entire of the eye tracking model, or after that we use also emotion recognition model inside of this project. Entire of the calculations is happening the user computers. It means there is no GDPR problem. Basically, I can just see the final results. I cannot see the face, the eyes, anything. I am just seeing the numbers, not the photos or any video. It's quite GDPR friendly. Okay, this is. I'm so sad you cannot see, but basically this is our RIF model. Is emotion recognition was here. Also, it's me. So, and this is web case coordinates. Every seconds we could see. I mean, here I can see, but you cannot see. Basically, every seconds there is a coordinates of X and Y coordinates from the eye, and there is an emotion recognition results basically. So let's see what kind of limitations we have, because as you know, every system has some sort of threshold or bottleneck. So this is our memory usage and average memory usage. Basically, when we start to data collection, after the like 14 minutes, our memory usage are increasing. So what that means? Do you know RAM, right? RAM, random access memory. So your computers are using random access memory. Every minute, your random access memory usage is increasing because the system is using with a live way and basically taking data, calculate that, and sending back another computer via internet. So it's increasing every minute. I can show you here. So average increase between seconds is 0.0037. It means really small, but average memory usage was 72.52, and memory usage is not that big, but we can say if you want to use this system like 3 hours or 4 hours, yeah, there is a limitation, because after 3 hours, it's going to be your random access memory will give an error. Yeah, there's the average memory usage, and there is average increase between the seconds. And this, as I told you, this system is suitable for medium, long experiments. Yeah, long experiments are okay. 1 hour is okay, 2 hours is okay, but after 3 hours, we tried that. And if you ask me, theoretically, I can say 3 hours, but we tested under pressure. It was 4 hours and 25 minutes with 660 gigabytes of random access memory. So it was working for 4 hours. And thank you for your time. If you have any question, I can answer that. And also, this system is still active. Basically, we are still using it.